Hello friends, welcome to Tech Greens. In the continuation of our Hadoop tutorials, today we'll look at what is rack awareness in the Hadoop world. So before we go into rack awareness, let's try to understand these physical machine level terminologies like data center, racks and nodes. So if you look at the picture here, so data center is the place or is the set of hardware machines where you would have number of racks, and on each rack you would have physical slave machines which are called nodes. So if you try to put this picture in analogy with the Hadoop cluster world, so you would have your Hadoop cluster set up say on one or more data centers, and all the slave machines would be the different nodes across different rack in that particular data center. So that's how you will create your Hadoop cluster, so that on a particular data center where you could have a Hadoop cluster across data centers, but it will be same on individual data centers, so that on each data center you would have different racks being available, and on those different racks you will have number of different nodes which are forming the Hadoop cluster. So now we have understood what is a rack. So rack, you can say, is a collection of different physical slave nodes or slave machines, which are the different nodes in the Hadoop cluster. So one of these nodes would become the name node, and rest of the nodes would be data node. So that's how Hadoop cluster would be formed at the physical layer. Now let's try to understand what is rack awareness in the Hadoop. See, the concept that chooses closer data nodes while storing the data blocks based on the rack information, and this rack information is maintained by the name node in the form of rack IDs. This whole concept is called rack awareness in Hadoop. That means the Hadoop cluster via name node is aware of the different racks which are available as part of that physical Hadoop cluster, and whenever Hadoop will try to write data to any of the data nodes, it will prefer to choose a particular data node which is closer closer to the client based on the rack IDs maintained by the name node. So this whole information in the form of rack IDs is stored by name node, and as Hadoop cluster is aware about different rack IDs in the Hadoop cluster, this whole concept is called as rack awareness in Hadoop. Or in another definition of rack awareness is the information that what is the cluster topology, or how the data nodes are distributed across the racks in the underlying data center in a particular Hadoop cluster. So that knowledge about the cluster topology and the location of each data node, that on which particular rack it exists, makes Hadoop as a rack aware system, and this concept and this property is called rack awareness. Um, let's try to understand why do we need rack awareness at first place. As the entire Hadoop Hdfs always creates a replica of each data block. There would be by default 3 replicas of each data block, uh, which is critical and as part of the design to make the system highly available and fault tolerant. So each time you have any data block stored on the HDFS, Hadoop system will make sure that you have two more replicas, in total 3 replicas of a single data block available on different data nodes and across rack. So if you understand it at the first level, if you will have it across nodes, say in the same rack, and suppose if that particular rack fails, then all the data, in spite it's replicated, would be lost. Now comes to the second level of granularity. Now here in this design, what we have done, we have distributed the replicas across racks. So even if in case one rack altogether is down, which happens very rarely obviously, but if in case it does go down, and still we have the replica of that particular block is available on another rack. So this whole replication management, which is done by Hadoop, is called replica placement policy. So this is a policy which defines how a replica of a particular block would be placed across different data nodes in the entire cluster. And what this policy exactly states is that there would be no more than one replica in one particular data node, and there would not be more than two replicas on a single rack, because we have to maintain in total by default three replicas. So we make sure that at least one replica will go to the another rack, so that, as we have discussed, if in case the entire rack goes down, it is still available on the another rack. So this whole placement management of replica, how it is done in the Hadoop, is called as replica placement policy. Let's try to understand this policy with this picture. So here we have got three racks, and racks on each three rack there are four nodes each. And say we are trying to save a file where we have, for that particular file, we have got three blocks: block A, B, and C. So we have got block A, block B, block C. Now for each these of three blocks there would be three more replicas. So in total there would be 9 blocks that needs to be stored across nodes and racks. So let's see what happens. If you see, when the client is ready to load a file into the cluster, the content of the file will be split into different blocks. Each block would be of 128 MB by default. Then that particular client gets the metadata information from the name node, that where it needs to store the three replication copies for every block. And then name node gives the address of three different data nodes based on the replica placement policy, which, as we have discussed, says that there cannot be more than two blocks of the same, two copies, replicas of the same block on one rack. So here you see there are already two replicas of block A on rack 2. So that means the third copy cannot be on rack 2. It has to be either on rack 1 or rack 3. So here in this example, it is on rack 1. Similarly here for block B, green blocks, on rack 1 there are already two copies. And now you also made sure that on single node there is only one replica. There's only one replica of each block. On a single node there cannot be two replicas. Similarly, green block is two replicas are there on rack 1, and the third one is on the rack 3. So this is done based on the replica placement policy which we have discussed. On each node only one block, one replica of a block, and on one rack across nodes can only be two replica of a single block, cannot be three. Now let's try to understand it with an example, like what happens exactly when you try to create a block. So as soon as you try to create a new block, let's say you're trying to save some file in the Hdfs and blocks are created. So first replica is placed on the local node. So whichever is the closest to the client which is trying to write that particular file. So first block will be placed on the whichever is the local node. The second one is placed on a different rack. So second block would be placed on a different rack altogether, and then the third replica would be placed on a different node at the local rack. So on one rack, on two nodes there would be two blocks, and on the second rack it would be the third replica. And even if in case we were trying to do a re-replication of a particular block, same policy would be followed. If a number of an existing replica is 1, then second would be placed on the different rack, and then third would be placed on the first rack itself on a different node, right? Let's try to understand what is the design theory, that why we have not kept all the blocks all together on the fresh racks all together. Why we keep two blocks on one rack? So see, here we have to understand the design trade-off that we have. So one simple way could be that each block or each block, replica block, could be across along all the racks in the data center. So they say we keep individual blocks or individual racks. But in that case, try to understand, when we'll try to read that particular data block, there would be enormous amount of network overheads, because every time you will have to do a read, you will have to engage three different nodes. And similarly, whenever you have to do a write, you have to engage three different nodes. See, whenever you're trying to write a single file, you will have three replicas and you will have to engage with now three different racks. So your network latency would be very slow. So that's why a trade-off is taken, because rack in altogether doesn't go down as often. So we make sure that it is across racks, but not more than two if replication is three. So this gives a good mix of that, network overheads are also less, but at the same time fault tolerance is also guaranteed. What are the different performance? Obviously, the performance aspect is, in spite it is spread across racks, but we make sure that it doesn't go beyond two racks. So your bandwidth utilization would be less and your latency would be less, which makes the write operations much more faster, at the same time providing the fault tolerance. What are the different advantages, right? You minimize the writing cost and maximize read space using the rack awareness, read write request to the replicas on the same or the nearby racks. So the cluster is smart enough to identify which is the closest rack, as the information is stored with the name node in terms of rack IDs. So your data access needs are catered, keeping in mind that it is a minimum network travel. Uh, when it is the network overheads are less, probably you will save on your bandwidth and your latency will be less. And at the same time, nodes are assigned in such a way that they are closer to the client which are trying to, which have raised the request for read and write. Yeah, as it is spread across racks, if in case a particular rack altogether goes down, then the data block is available on the another rack. So guys, that's it in this particular video about rack awareness in Hadoop. We'll quickly reiterate that the replica replacement or placement policy is all about that there should not be more than one replica of a particular block on a single node, and there couldn't be more than two replicas of a node in one rack. So guys, have a good day. See you. Bye bye.